In this example, we're going to do what I sometimes refer to in class as a nail in the wheel question. A wheel picks up a nail, we're given the diameter of the wheel, and we want to know the elevation of the nail after the wheel's traveled 1 meter. Then in part B, we're given the speed of the tire, and we want to know the elevation after a given length of time. Okay, well, similar to the last question, the dependent variable in this question is height. Height of the rider on the Ferris wheel, height of the uh, nail in the wheel, very similar. However, this question is fundamentally different than the last question because in the last question, the independent variable was time. In this question, the independent variable is horizontal distance traveled. Very important difference. So there's a certain similarity, though, kind of like a Ferris wheel that scrapes along the ground at the bottom. We have a tire that touches the ground at the bottom. And because the nail is presumably, we can assume, picked up off the ground, we see that the nail starts at the bottom of the quote unquote ride and goes up. So, because of that, we can see that the height of the nail after any given length of time is going to resemble a negative coast curve. Okay? Now, the independent variable in this question is horizontal distance traveled. Well, we can see, hopefully, that after one circumference of the circle, the nail has gone to the top of the wheel and then back down again to the bottom. So that represents one cycle. Well, how long is that? Believe it or not, it's the same as the circumference of the tire. So, what is the circumference of the tire? You might remember from grade school math, it's 2 pi r. Because the diameter is 30 centimeters, we know the radius is 15 centimeters, so 2 pi times 15 is 30 pi. Okay, so the period in this question is 30 pi. Not 30 pi seconds, but 30 pi centimeters, the circumference of the wheel. Okay, so we can actually make a nice graph there with dependent and independent variables shown, both measured in centimeters. Okay, now the amplitude in this question is going to be equal to the maximum y value minus the minimum y value over 2, and that ends up equaling 15. The axis of symmetry y value, in other words, c, is equal to the maximum y value plus the minimum y value over 2. Since the minimum y value is 0, it's also 15. Now, there's no phase shift so long as we make our parent function negative cos x. If we make our parent function negative cos x, the cycle begins at x value of 0. So that's our d value. And since the period is 30 pi, the k value is, you might be tempted to say, 360 over the period. And technically you wouldn't be wrong, but we're about to have a discussion of why we might look at it a little differently instead. Okay? You can use radians or degrees in the Ferris wheel questions, and you can use radians or degrees in the nail in the wheel questions. No problem. But there's a certain logic regarding when to use which type of units of measurement for angles that might be useful to you, and I would recommend thinking. In the Ferris wheel questions, our independent variable is time. Our period is a rational number. In other words, our period is something like 3 minutes, which is 180 seconds, or 2 minutes, which is 120 seconds. Our period's a rational number. So if we use degree mode, we can let k be 360 over the period, and we get a rational number. For instance, 360 over 180 would give us a k value of 2. 360 over 120 would give us a k value of 3. So it kind of makes sense to put our calculator in degree mode and go from there. But in this case, our period is going to be, in this case, if we use radians, in a Ferris wheel question, we would have something like 2 pi over 108. Oh, yes, we'd have 2 pi over 180. And that wouldn't make much sense for a Ferris wheel question to use radian measure. 2 pi over 180 would give us a k value of pi over 90. That's an irrational number. So given a choice in a Ferris wheel question with a period of 180, would you rather say k is 2 or would you rather say k is pi over 90? Pretty much all of us would say we'd rather say k is 2, put our calculators in degree mode and go from there. But in this question, it's different. Our independent variable is horizontal distance. So if we let k be 360 over the period, we'd be saying k is equal to 360 over 30 pi. And when we simplify that, we'd get 12 over pi. Well, who wants that? Who wants such an irrational number as that? So instead, let's put our calculator in radian mode, and that'll make k be a rational number. Specifically, k, if we're in radian mode, is equal to 2 pi over the period. 2 pi over 30 pi is equal to, after the pi's cancel out, 1 over 15. We've got ourselves a nice rational number, and we got it by letting k equal 2 pi over the period and putting our calculator in radian mode. So, as we said, ultimately it doesn't really matter which method you choose, but you need to be careful of rounding errors. So as a result, many people find it convenient to let k equal 360 over the period if the period's a rational number, like it is almost certainly if the independent variable is time, or they find it convenient to let k be 2 pi over the period if the period's a multiple of pi, as it almost certainly is if the period is related to circumference. So remember, if you let k equal 360 over the period, put your calculator in degree mode. If you let k equal 2 pi over the period, put your calculator in radian mode. Gotta be. So getting back to our question, we're going to say k is equal to 2 pi over the period. If we say k is equal to 2 pi over the period, then we're going to get a k value of 1 over 15. Okay? So now we can make our equation. A cos of k x minus d plus c. Now our independent variable is horizontal distance traveled, so instead of calling it x, we called it d here. But since we have d minus 0 in the input there, we're just going to call it d. And we're going to say our horizontal distance traveled is given by negative 15 cos 1/15 d plus 15. Okay, now what's the elevation after the wheels traveled 1 meter? Make sure to put your calculator in radian mode. Convert meters to centimeters because both of this negative 15 and this 15 are referring to centimeters. And so that, in other words, we're going to let d equal 100. And when we plug that in, again, making sure we're in radian mode, we get roughly 1.09. So the height of the nail after the wheels traveled 1 meter is approximately 1.09 centimeters. Now, for part B, it says the speed of the tire is 54 kilometers an hour. What's the elevation of the nail after a minute? Well, we know distance is equal to speed times time. Well, the speed is 54 kilometers an hour and the time is 1 minute. But we can't nicely calculate kilometers per hour times minutes unless we convert to the same units. So what we're going to do is convert 1 kilometer to 1,000 meters and then convert that to centimeters. So 1 kilometer is equal to 100,000 centimeters. And so we're going to be able to say that 54 kilometers divided by 1 hour is the same as 5,400,000 centimeters divided by 60 minutes. And what happens here is these units of minutes here and here cancel out, and we're just left specifically with centimeters. And we can say that our distance is equal to 90,000 centimeters. We can then plug that into our calculator, again making sure we're in radian mode, and we ultimately get a value for h of roughly 1.44. So the height of the nail after 1 minute is approximately 1.44 centimeters.